Okay, I just wanted to make sure that you got why this was called a double root, because this part right here came from setting this equal to 0. And if we did the same thing again, 2x plus 3 equals 0, we would get the same answer. So that's why it's called a double root. The word root, oh goodness, the word root has not been talked about. And it will be coming up shortly, but just for future reference, we're finding these are solutions, because that's what you find when you solve something. These are solutions, but solutions and roots, solutions and roots and zeros, and you'll understand this part a little bit later. Intercepts. Intercepts. These are all words that can describe what we just found right there. And you'll, like I said, solutions you get, roots is just another word. Zeros and x-intercepts. Zeros because the numbers that we just found, if we plug those numbers in this equation up here, it's what creates a zero. And you'll see in a minute that when you graph this on the graphing calculator or Desmos, you see that this is where this graph right here is going to cross the x-axis. Okay, so, so this one looks like it's a binomial. It's not a trinomial. So is this a dot? Well, it's definitely a difference, but this is not a perfect square and neither is this one. But I do recognize that those are both even numbers. So if I factor out a 2, undistribute a 2, 18 divided by 2 is 9, 98 divided by 2 is 49. And now you recognize that this is a dot. Yes, it is. 9 is 3 times 3, 49 is 7 times 7. So this factors out like this. And the 2 just kind of hangs out, or actually we could divide both sides by 2 right now and get rid of it. But I'm just going to take the 2 factors that are involved with the x and set each one of those equal to 7. Set each one of those equal to 0 and solve. So 3x is equal to negative 7, divide, x is equal to negative 7/3, add 7, 3x is equal to 7, divide by 3, x is equal to 7/3. All right, so those are the solutions, the roots, or the zeros. This one's different because it's not set equal to 0, but it doesn't matter. If it's not set equal to 0, then that's going to be the first step to factor. The quadratic must equal 0. So this needs to be 0. So how do you make a negative 8 0? You add positive 8 to it. And what we do to one side, we have to do to the other side to maintain equality. So x squared plus 6x. No, you can't really add those together. Why? They're not like terms. You can't add the 8 and the 6 together. The 6 is attached to the x. That's 6 x's. You can't add 8 to 6 x's. So now that we have it set equal to 0, now we have to judge what kind it is. What kind is it? This right here means it's an easy table. And an easy table means we put 8 on the table, positive 8. And how do we get positive 8? 1 times 8, 2 times 4. 1 times 8 means a positive 1 and a positive 8. That gives me a 9. A positive 2 and a positive 4 give me a 6. This is what I'm looking for. So this is the pair. X, X, a positive 2, a positive 4. Set them both equal to 0. And solve each one of them. X is equal to negative 4. Okay, last one over here. We're going to take this one. First thing we have to do is set it equal to 0. How do we make that 3 become a 0? Subtract 3. Subtract 3. This becomes 5x squared plus 2x minus 3 is equal to 0. This number right here means it's not an easy table. Check to see if there's a GCF. And 5 is a prime number, 2 is a prime number, 3 is a prime number. So no, those don't share any common factors. So that means that this is the AC method. And the AC method means that we multiply A times C. To pretend for a minute that this is the easy kind, 5 times 3 is negative 15. So negative 15 is what goes on my table. Well, I can obviously multiply 3 times 5 to get 15. This number needs to be a positive, so that means my little number is a negative. Multiply those together, you get 15. Combine those together, and you get a positive 2. That's the one that I need. Of course, I could have also done 15 times 1, but 15 times 1, if you make that be a negative, that would give me a 14. This is the one that I need. So I'm going to use this pair. So it's x minus 3 and x plus 5. Remember, this is the AC method, so I have to undo the multiplication. So I've got to undo multiply by 5. So that means I got to divide this by 5, divide this by 5. This one doesn't divide out. So I swing the 5 up in front. And now this is 5 divided by 5. That's just x plus 1. Take each one of these, set that equal to 0, and solve. Divide by 5, divide by 5. X is equal to 3/5. Set this one equal to 0. Solve. So x is equal to negative 1. And I believe that's all the time for this one. So I'm going to go ahead. I'm getting close to the time, so I'm going to go ahead and stop. And then I'm going to show you, I think I'm going to show you this one right here. On the calculator, on the Desmos.